For humans, we contextualize data all the time. You'll see something really dumb in data and you'll just discount it. Algorithms and all these measures and KPIs are naive. They believe whatever is in the data. They do exactly what you tell them to do.
Welcome everyone to another episode of Hidden in Plain Sight. I'm your host, Chad Grills, and today we're talking with Dean Abbott. Dean is the co-founder of SmarterHQ, a customer intelligence and personalization platform. Dean has been applying data mining, prepping data, and applying data visualization methods to business and research problems since 1987. In today's episode, we cover a wide range of topics, including how Dean got his start in defense work and went on to build models to help fight fraud. We talk about the importance of framing questions before diving into the data, and why data preparation is a critical art. Finally, we touch on how the future of AI might be one with way more jobs than anyone anticipates. Let's jump into today's episode of Hidden in Plain Sight with Dean Abbott.
This season of Hidden in Plain Sight is brought to you exclusively by our friends at Splunk, the Data to Everything platform. Splunk helps organizations worldwide turn data into doing. It's time for data to be more than a record of what happened. It's time to make things happen. Learn more at Splunk.com or by clicking the link in our show notes.
Dean, welcome to the show.
Thank you very much. It's a real pleasure to be here.
It's a pleasure to have you on, and you're calling in from San Diego, California. I'd love to start out with, what's going on in your neck of the woods. There's so much going on around the world right now. What's going on in San Diego today?
Yeah, San Diego, very thankfully, has been spared a lot of the most severe impact of COVID-19. So the number of deaths is relatively low. So it's been good from that standpoint. But we are in California, and our governor has been taking it very seriously. So things are pretty locked down still in San Diego. We are opening up for a while, and things have been pushed back. But I think the beaches were still open, though. I haven't gone to the beach for a while, but there are some openings. But I'll tell you this, July 4th, I was surprised how many fireworks were firing off from private residences. I'm sure most of which was illegal, but people just had to vent on July 4th.
I was shocked when I saw some helicopter footage of the amount of fireworks going on. There's some great footage of these skies above LA on the 4th. And it is just I've never seen so many fireworks, actually.
I heard about that.
Yeah, never seen so many from private residences.
I had not either, because I remember back in the years ago, I was spending a summer in New York City in Bay Ridge in Brooklyn. And on July 4th, it was crazy till like 1 or 2 in the morning, all the fireworks going off. And this was the most I had seen anywhere since that. I concur with that. It was crazy how much was out there.
So as we shift into the topics today that we're going to be covering, I'd be really curious to know, how'd you get your start in technology and data? And, how do you describe your passion for this? Where did it come from?
It's really interesting. You don't know. When you're in college, back when I was at college, just a long time ago. So undergraduate was in the early 80s. I loved math. I was a computational math major, minored in electrical engineering, and did a lot of computer science things. So I was interested in numerical analysis because I thought that was a good combination of math and computer science, because computer science was just starting to spin up to be such a critical field. And so when I was going through all that, I just liked numbers and liked the data to understand what the data was saying. But there was nothing like data sciences today. There's no field like that. I mean, there were statistics, but I really didn't know anything about it. Went to grad school because I felt like I didn't know anything of value. When I went through my interviews with companies like IBM and MITRE and companies like that, I realized I don't know anything that I can help them with. So went to grad school. But as a result of grad school, I latched onto a company, did an internship, and finally was hired by a small company in Virginia because I was at the University of Virginia. And this small company of 5 people was doing a lot of data analysis. And my interest was in optimal control at that point, because I was a math guy and I love differential equations. I know that's really weird, but I love differential equations. What do you do with that? You do things like control theory and optimal control. And so I love doing that kind of work. And I was discovering that one of the ways to solve these very complex systems of equations problems is with simulation and just running simulations over and over again, then analyzing the data after the fact. That's what I do with this company. We were doing things like missile guidance in the early smart bomb days. But the secret sauce, and this is the connection with data analysis, the secret sauce was that it was too complex of a problem to solve in real time. So we would simulate these trajectories. You imagine like smart bombs, trying to figure out what's the optimal way to guide them. We simulate them backwards from hitting the target back in time. And then we built predictive models, statistical learning models, to say, I am at this point in space, I'm trying to get to this point in space of all those thousands of trajectories that are all optimum, which one am I most like? Which one should I jump onto? And we used a technique which is similar to neural networks, so it's called polynomial networks, to encode in real time the nonlinear mapping from my current state to the state where I want to go. And that was my introduction to statistical modeling. And that company, with just a few people in that company, most of the people in the company went into what is now known as the data science space because it was so cool. But this was the late 80s. So this is the very early days of this kind of data analysis, at least at scale.
That's fascinating. And I'm glad polynomial neural networks got rebranded, or however you identify it now. I guess just neural networks is the good catch-all.
That's the closest technology to it because it was really different. It really was basically linear regression, nonlinear inputs to linear regression models, and then layers of these models, which is so the closest analogy to what we do now is neural networks.
Sure. And as you progressed in your career, you went on to co-found SmarterHQ. What were some of the big moments along the way that you remember where you thought, okay, this is just going to be a massive field. This is going to be a huge need for all kinds of institutions and individuals in the future. What were some of those moments along the way that just, really ignited how you saw the field and what you thought was coming down the pike?
That's an interesting question because all along, I just love data. It's like a dog with a ball. You throw the ball and the dog will go after it. So throw me some data, and I was happy as can be. So whatever that application was, and in the early days, it was mostly Department of Defense applications. I mentioned missile guidance. I did sonar, passive sonar and active sonar to detect objects underwater, a lot of things like that. But the more work we did, it's like there was a seemingly endless supply of problems to solve once you had data. And so in the 90s, when I had more experience under my belt and was starting to think about how I could progress in my career, I was seeing more and more just the need to be able to translate these problems, to try to solve problems in a useful way for the end customer. So one of the first examples of that I saw was I was working on a consulting project with the Defense Finance and Accounting Service. And they were trying to identify from all the millions of invoices that came into the government, which one should they investigate? And they could only investigate 100 a month. And so we had to rank order all the invoices with the riskiest ones for them to investigate. And the thing is, it's not just a matter of building a cool model. It's taking that model and putting it in the context of the problem they're trying to solve, because they didn't care. They literally didn't care about the 990,922nd ranked invoice. That's irrelevant to them. They just had to get those top 100 really good, productive work for their investigators and find those. So we had to change the way we built the models to adjust to what problem we're really trying to solve from their perspective. That's what really got me jazzed, is to try to take these advanced mathematical concepts and try to put them in the right context for the business to be as successful as we can for the business. And it's not just a matter of data in, run the algorithm, and you're done. A lot of thought had to be put into place for how to judge what is considered best. What is the best model? Because a model that did well at the bottom of the population was irrelevant. Only the ones that were tuned to do well for the very extreme tail were the good ones for us.
Sure. And at the start of this process, it really gets down to asking the right questions, or asking many questions and figuring out what the right ones are. Could you maybe tell us a story about, as you progressed through your career, how you got better at formulating the right questions to ask, or the right questions to start with?
Yeah, that is really hard. I think, to me, that's the biggest challenge for the data science and AI community today, especially for the technical people like me who've been trying to help businesses and organizations solve problems. And it's because we don't speak the same language. So the data scientists speak in terms of, we might talk about neural networks or GVMs, gradient boosted machines, or XGBoost. And we're talking about precision and recall and all these really cool measures that we're used to using. And those people we're talking to in the business world, they have no idea what we're talking about. And they're distrustful of data because they've seen the abuses of data. Or in a better way to think of it maybe is they want the data to speak as long as it tells a story that they agree with. So they'll often say, yeah, let's see what's in the data. And then you tell them what's in the data and they're like, yeah, I don't like that. Make it say this. And as an analyst, you want to be fair to what the data is. So in those conversations, one of the things I try to get them to do is explain to me how to best, how they will use the models that they want to build. Because they may say, I want a model that is going to generate more revenue for the company. Let's say it's like with SmarterHQ, we do a lot of customer analytics. So let's say they want to generate more ROI or generate more revenue from an email campaign. Okay, that's great. So more revenue. What is, if you had a model that generated $1 million of revenue, but caused a 10% unsubscribe rate, would that be acceptable? And then they think about it and go, no, it has to generate a lot of revenue, but subject to these other constraints. And they won't say it like that. They'll say, yeah, but we can't have that because in the long run, we'll lose clients, we'll lose customers, and we need to keep customers for the long run. I said, okay, so really what you want is you want a model that does well in the near term, but preserves long-term engagement with these shoppers. And yes, okay, so what does that mean? How long-term do you want to think? Do you want to think a year? And the more questions you ask to uncover those hidden assumptions that they have, the better off you are. It's really hard for an analyst to do that out of the box. You have to live with these stakeholders for a period of time, have those conversations to learn what they really want and try to uncover those hidden things that they assume is obvious, but it's not obvious. Just like as an analyst, there are things that are obvious to you that are not obvious to the stakeholders. There are things that stakeholders live with that are not obvious to the analysts. It takes communication over a long period of time and tuning your mind, your thinking to pick out those key phrases they may utter, even without them knowing that they're uttering a key part of the equation.
That's really interesting. And I'd imagine too that no matter, how much communication there is initially, there are going to be second order or third or fourth order effects that are, you could call them random or emergent, that could not have been predicted. I'm really curious to know, what are some of those that you encounter when working with companies, and how do you adjust the models when these second and third order effects start to emerge that are negative or maybe positive?
Yeah, one of the keys to that is getting models that, whether they're in production or in what I would call shadow production, that they're being used as if they were in production to see what they do. Because you can speak at the level we're speaking at right here, which is conceptual, and it's really interesting. But conceptual level discussions are valuable, but it's only when you get into the weeds of the data that you really start understanding what's going on there. So let me give you one example. I did consulting with the IRS for about 10 years. And I was speaking with a subject matter expert once about what things do subject matter experts and this was for S corporation tax returns. We wanted to find indications of risk of non-compliance on S corporation tax returns for medium and large businesses. And so this subject matter expert said, well, and I'm making this up because I don't remember the exact line items, but he said, well, if M3 line 2 divided by the top front page line 23. If that ratio is greater than 3, then that's a weird thing. And that would be something I would want to look at and put and give to an auditor to examine. I said, oh, cool. That gives me a feature that I should build. So I built the feature. So the first thing I did was I built it, applied it to the population, and then showed them what it looked like. I said, I'm finding these examples where that ratio is like 50 or 100. Does that make sense to you? And he scrunched a little bit. He said, well, what is the total assets of companies like that? I said, oh, they're like, $1 million or $2 million. He goes, oh, no. I would never apply that ratio for a company so small. These are really for companies that are maybe 50 million in total assets and above. Okay, good note to self. Now, for him, it was obvious because for humans, we contextualize data all the time. You'll see something really dumb in data and you'll just discount it. Like you'll see the age of a shopper, and if the age says this shopper is 150 years old, you discount it and say, okay, that's not real. Algorithms and all these measures and KPIs are naive. They believe whatever is in the data, and they believe they do exactly what you tell them to do. So when I built these ratios that had these huge values, he knew right away that they were wrong, or they weren't worth pursuing. From my standpoint, I had no idea because I didn't have that intuition. I didn't have that context to know what was considered good or not. So that's why the feedback loop is so important, to have them describe things that are important about the process. You build the model, or you build features and measures, show them those to help them contextualize for you which ones of those are real and which ones of those are fake. Because there's a lot of outliers, a lot of junk, garbage in data that will throw us off, and the models really don't know any better.
Really, really interesting. And that junk, data or the information that clouds the models, I'd imagine it comes in all shapes and varieties. How have you gotten better at filtering that out or parsing that out at SmarterHQ? And how does the software kind of, get rid of some of that up front?
Yeah, one of the ways to do that right up front is looking at outliers. So when you're looking at, for example, if we're building a customer lifetime value model, and the first thing you need to do is build a target variable that has what the customer value is. And we almost never build, I almost never build truly customer lifetime value, because most of our clients are more interested in how much revenue do you expect from shoppers in the next month or the next 3 months or the next year. So the time horizon is shorter than their lifetime. I mean, things change so much in 2 or 3 years, so it's hard to know or hard to even care about what's going to happen 10 years down the road. So when we do that, the first thing you do is build that target variable. And then all of a sudden I'll see for a regular retailer, somebody who's a shopper whose total revenue is like $10 million in the next year. I was like, wait a second. What shopper is going to be buying $10 million worth of stuff in the next year? And then you discover, oh, well, that's a shopper on the site, but they really are a business that's buying in bulk lots and lots of stuff. So they're really not a shopper. And what the retailer was interested in is a consumer level model, not a business level model. Okay, good note to self. That's an outlier. That is, from our standpoint, that's junk or noise in the data from a consumer standpoint, though it's valuable in another context. So in that case, the data isn't necessarily wrong. In other cases, the data really will be wrong. I mean, there will be something, we're using JavaScript to pull data off the shopping cart page in the final transaction. And maybe the transaction was supposed to be, $322.16. And somehow the data was miscollected and it's $32,000. So those outliers show us a lot. So that's the first thing. Build the measures and metrics, look for outliers. Look for things that are unusual, unexpected. And to assess what's unexpected, you have to know something about what's expected. And averages are helpful there, but averages are not the end. I really like to look at the tails. So averages tell you on average what's happening. And as the old joke goes, averages on average are wrong. The tails are where the most interesting parts of the data reside from a data quality standpoint.
And when you're looking at the tails and you do find the outliers, you filter them out. Occasionally, though, when you come across an outlier, do you come across something that's really valuable for the model? Are there any
Absolutely.
examples when you get rid of the noise and eventually you find something there that is an anomaly? How do you encounter those positive anomalies?
Yeah, so that's a very important question because anomalies and outliers are just that. They're anomalies and outliers. And there's two kinds of anomalies or outliers. One kind is true and one kind is false. So if it's wrong, then we really don't know what the value is, and those should be either removed or converted to null, or we need to replace it with something that is more representative of what it should be. But sometimes they're true, they're real. And those real values that are in the data, we have to then make a decision, should we keep them or should we not keep them? And that decision is based upon a bunch of other factors, such as what's the real purpose of the model. I usually like to keep those outliers in the data if possible, because that's the context of everybody I want the models to be aware of. But that means that some algorithms like linear regression or principal component analysis or k-means clustering or k-nearest neighbor or Cohonen self-organizing maps, there's a lot of algorithms that are built on what I would call squared error metrics. So you looking at things like Euclidean distance for k-means clustering or k-nearest neighbor, or linear regression is minimizing squares of errors. That squaring part that you do for Euclidean distance or for linear regression will amplify the outliers and make the outliers dominate. So the algorithm you choose to build models when you have outliers is critically important. If you build a regression tree, for example, you should be fine. If you build linear regression models, you've got to be very careful about those outliers and how they're represented to make sure that they don't dominate your model. We could go down that path, which is a super fun discussion, but that's a very important discussion about how data preparation of all the data you're using to build these predictive models, machine learning models, how critical it is to know what algorithms you're using before you begin preparing the data, because you prepare the data differently for different algorithms.
So I'd imagine if it's an exciting path to follow for you, there's something pretty big there. So, why is that exciting for you, and how can companies get better at preparing their data?
Oh, it is really exciting because mostly it's because I've made so many mistakes over the years with this. I've been surprised so often with model results that I scratch my head. Then when I look at it, I discover that it's something in the data, the distribution of the data, or I find outliers initially and I have to decide what to do with those outliers. And let me give you one example where understanding how the algorithms work changed how we prepare the data, and we broke all the rules to build a better model. So I was building models for another tax agency, and they wanted to predict how much tax an entity owed who didn't file a return. So you can imagine it could be a personal return. You don't file a return. How much do we expect you owe? Because that will change what your collection procedure is. Do you send a soft letter or a hard letter? Or do you send an agent after them or something like that? Because it's a real value prediction model, we're trying to predict a value like $1,000 or $5,000 or $10,000. So you're trying to predict that. So when we're doing that, we first did and I'm using my scare quotes, all the right things. So we're building linear regression models because that's what they wanted with this particular agency. I said, okay, fine, we can build a linear regression model. So we constrained the outliers. We made the target variable, how much tax was owed, a normal distribution as best we could. We changed the distributions of all the inputs, and we built our model. And the accuracy of the model was okay. But one thing we noticed was that we are getting relatively big errors at the high end of the distribution with the people who owed the most. Okay, so why is that? Well, the reason that is because we constrain the outliers, and there are relatively few of them. The techniques we use, like log transforms or Box-Cox transforms, to pull in those tails, made those data points less important. There are fewer of them, so the model worked harder to get the center of the distribution right and was willing to accept errors at the tails. Now, for them, that was a big deal, because certainly where you don't want to make a mistake is with the people who owed the most. You don't want to think somebody who owed $15,000 in tax really only owe 2,000. Whereas in the normalized units, after you scaled everything down, that may not be that big of a deal, but in real dollars, in the natural units, is a big deal. So we had to think about how to recast the problem so the models were biased to pick out the most important cases, which were the tail of the distribution. What we ended up doing was just one way to do it, is we said, okay, well, let's not scale the data. Let's leave the outliers the way they occur naturally, which means the models, the linear regression models, will be naturally biased toward that tail of the distribution, but it will do better there and make more errors in the center of the distribution. And that model was much more valuable for them as an organization than the model that was done statistically correctly. So that's where it mattered a lot. Now, if I was building a decision tree or a regression tree, I wouldn't have worried about it at all. But because we're using linear regression, we did the right thing that generated the wrong result until we flipped it, recognizing how we could get the right answer doing the quote unquote wrong thing with the data, if that makes sense.
Yeah. And so I'd imagine the breadth of the companies you work with is all over the map at SmarterHQ. What are some of your, I'm sure you can't just pick like a favorite industry. What are some industries that lend themselves the best to this type of analysis? Is it every industry? Are there a couple examples of companies you think that are just like perfectly suited for this type of analysis?
Yeah, that's an interesting question because SmarterHQ started primarily working with retail. So especially apparel and things like that. So you've got shoppers who are engaged in the website, they're visiting, they're revisiting. You can collect really rich data, very interesting data about shopper experiences. And one of the critical parts of that is trying to figure out who the shopper is. So you come in on a Chrome browser, and then you submit your email address because you want to get marketing emails. Then you come in on your phone in like Safari or something on your iPhone, and you reveal who you are. And we want to stitch those two together so we understand how you interact in the different ways with the with that particular brand. And those are really interesting cases. And that's when you get a lot of data, it makes it a lot easier to figure that out. Some of the really interesting cases for us are especially things that don't immediately seem like they're great fits. So one of our clients is cars.com, and that's a different business model. So you're online looking for cars and you don't actually buy anything. You're just trying to find cars, and you contact the end buyer. But the same core technology to identify interesting behavior applies because you're browsing. But instead of the end result being a transaction, the end result is a connection, like trying to find or collecting the information you need to connect with the seller of the vehicle. And with them, everything is an inventory of one. You don't have like a 100, flat shoes or 200 tops of this particular variety. There's just one and only one of each. But the technology works the same way because the data, when we collect data to build predictive models and build all these metrics we use, the analytics doesn't care what the domain is. We just have to define those elements, what it means to be engaged on the website. What does it mean to quote unquote transact, whether that's a real transaction or whether that's getting more information or signing up for a newsletter, or for our financial services companies, it may be filling out a form for a credit card application. And that's the end result. But all the data that feeds into that, all the behavioral data you do on the site connects to that end result in a very similar way. So it's really fun to see how human behavior replicates itself even in different verticals.
Yeah, and I imagine that the similarities are quite just all over the place as you start to go to different industries. Yes. Dean, shifting gears a bit, I'd be really curious to know, do you have any beliefs or ideas about data, big data, the industry as a whole that some people might consider heretical? Are there any beliefs that you have that are just, completely against the status quo? And if so, would you be willing to talk about them a little bit?
Yeah, there's a couple. I was thinking about that question, and there's one thing that's probably going against at least the leading edge or the bleeding edge of AI these days is I really don't think that machines are going to replace humans in decision making or even data scientists in my lifetime and not even in my kids' lifetime. So I'm in my mid 50s. So even if I've got 30 years left in my lifetime, I don't think we're going to see vast numbers of data scientists replaced.
It's so interesting you brought this up. So one of the things I was just reading about was the Bureau of Labor and Statistics just revised all of their figures around new jobs. And so a lot of the industries where AI is predicted to impact it the most have the prediction of more jobs coming online for them. So if we take the example of like ATMs, for supposedly they were going to replace tellers, they ended up creating more tellers because they lowered the cost of that banks could now set up all these mini branches everywhere, and they ended up needing to hire more tellers. So it's there's just this whole emerging field of it's not doom and gloom, and in fact, it's just we're going to need way more people in these industries that are supposedly going to be replaced. I'll shut up. Sorry.
Oh no, that was really a really interesting example because I was thinking about that because I hadn't heard that before, especially with bank tellers. And you would think that with more ATMs, it would reduce the need for tellers. And even when I go into a bank branch, I mean, if I want to take out money or do anything, I'm using essentially, all the pad that's right there to do everything. But so then the next question is, why do they need more tellers, or why are more tellers needed? That means that there are things that they weren't able to do before that now they can do because people are freed up to do the things that humans do much better. And that this gets back to what I was getting at before with context, that machine learning, AI, is fantastically fast and accurate when you've got good data. But you're limited. I mean, all those algorithms are limited by what they know. And all they know is that data set you give them. And that's it. And somebody has to build it for them. Because if you just take raw data and throw it into a database and tell the algorithms go for it, there's very little data they could use. So I was thinking about this recently. I was looking at all the stats about how much data we're collecting. And, like IDC, I think was even 10 years ago, saying every 2 years, we're doubling the amount of digital data we have available to us. And that trend is continuing. It's almost like the Moore's law of digital data. And so that's a lot of growth. But they said the vast majority of the data is not looked at or used for anything. Only, I think I was reading recently, only maybe 37% of data is usable.
Wow.
So what does that mean? That means that the machine learning algorithms and AI needs the data in a specific form to be useful. And that makes sense because this is just math. It's just, and they all work the same kind of way. It's loadable in a spreadsheet. You've got rows, you've got columns. That's how linear algebra works. That's how all these machine algorithms work. That means you've got to take data like Internet of Things. You're getting data from your refrigerator like every millisecond, new data about everything that's in your refrigerator. And you want to build a model to predict when you need a new gallon of milk. So you're collecting all this data in real time. You need to know something about the consumption of that, the rate of consumption, and all that. But the final answer is a decision about buying milk. That means you've got to translate all of that very granular data, which I can guarantee you milliseconds of data is not useful for looking at milk. It doesn't drain that fast. There's a different resolution. Right. So you already have to aggregate it up to a certain level to be useful. And then you've got to combine it with other things about family preferences and when you're having guests come and all those things that that data doesn't know anything about. So to have a really good decision, a decision that a human makes, there's more data that's needed than just those obvious things, those easy things to collect. And that's why I think humans are going to be needed in the loop for a long time to bring more context so that we can make decisions more the way humans make them.
Definitely. And that human component is going to be very interesting as we watch it evolve, and like the needs for empathy and creativity.
Oh, yeah.
And I mean, we're we basically don't even have a good idea of what those words will mean in the future. But how do we expand human capabilities there? We touched on empathy and creativity. It seems like these are crucial skills that we need to be developing now so we can complement the machines and better, augment ourselves with this technology. How do we expand those skills, and what skills do you see future humans needing to master?
That's a big question. So I'd say one of the things that helps humans make decisions, good, bad, or, the good, the bad, and the ugly of all the decisions we make is, you're right, it's not just the facts on the table, or it's not just the immediate data that we have available to us. There are other things. You talk about empathy, and there are psychological implications. And the cost function, so put it in more mathematical terms, the cost function that people use to determine what is the best solution is different for different people. And it's hard to come up with a single objective, unidimensional answer. And so one of the things, going back to a question you asked in the very beginning, is when I'm working with stakeholders and how to understand what they really want. One of the techniques I use to try to understand what they really want is to give them comparisons, not just to have them explain what they want, because we're really bad at explaining exactly what we want, especially contrasted with all the things we don't want. But people are much better at saying A versus B. Which would you prefer? With all the COVID stuff and the examples with COVID, what's the best course of action? I mean, we're all over the place because people have different objectives in mind for that. But if we did like a customer analytics example, yes, we want to maximize revenue, but we want to maximize revenue subject to other things like reducing unsubscribe rates because we want the future to be brighter. We want to also be able to push people to buy more products because we know that the more categories that people are engaged with, the stickier the brand is to them. And so there are all these additional dimensions over and above just will they purchase the next 7 days that are important. And so this is multidimensional optimization. It's very difficult to trade off into a single measure. So that's one of the things I asked them and said, if you generated $20,000 from a campaign that we had in the next month, would you prefer that even if you lost 10% of your subscribers, or would you prefer to have a strategy that only generated $5,000 in campaign revenue, but in 6 months kept 95% of your subscribers subscribed to the emails, and try to help them look at those alternatives. And it's like squeezing a balloon. You squeeze air out of one side and it goes into another side. So a lot of the decisions we make with marketing, especially, we're really trying to change people's behavior, hopefully for the better, by giving them what they want. But by doing that, it's never in a vacuum. It's like the Heisenberg principle. There's no such thing as a pure experiment that doesn't have other cause and effect. And it's impossible to have a perfectly controlled study. So people have to go in with their eyes open, knowing that if they do this, if we push people, say, who are web browsers to purchase in store, what is that going to do to their web experience? Is it going to change the web experience? Is it going to change the incentives your company has for those stakeholders who are just web-based stakeholders and they're not generating as much revenue online, and the in-store people are generating more revenue? I've wondered about this with Amazon, for example, with returns at Kohl's. What does that do to Amazon? What does that do to Kohl's, having this additional option available for shoppers? And it's an interesting question. So I've rambled a little bit, but these are multidimensional decisions that are very hard to nail down precisely, and different people have different trade-offs. And so those trade-offs are almost impossible to build out objectively. So we have to experiment and have to see how those play out, where those outliers, where those unintended consequences turn up, and then adjust to them as you see them arise.
Dean, when you think about the future of the industry, is there anything specific that you are very excited about? Is there anything that you're worried about? What does the future look like, whether it's a year out or 5 years out? Or is it impossible to predict?
Well, the joke I usually tell is when people ask me to predict the future, I said, I'm terrible predicting the future because predictive modelers live in the past because all the data is in the past. And you're just trying to uncover what happened in the past. And then you assume that's going to replicate itself in the future. But I'll bite and I'll talk about a little bit about the future with predictive modeling and AI. The thing I'm really excited about is that seemingly every industry cares now. So the stuff that I used to do in the back room, nobody knew about, nobody cared about, and it really didn't elevate at the C-suite very often, if ever. Now there's great visibility with data science and AI, and everybody wants to buy me some of that AI and print money for the organization. So that's really good, and it's spawned a lot of interest in the field. We were getting this deluge of data scientists popping up, which is good, but it's also bad because the bad part of that is I do fear that a lot of the data science that's being taught at the university level, as well-intentioned as it is really geared toward the technology, the software, like learning Python and R, learning how to build the algorithms. And it's not geared strongly enough toward building solutions for organizations that match their true business objectives. So communicating with the C-suite or communicating with the director or VP level is very difficult, and it's critical for these models to work well so that we don't have something happen like it happened in the early 90s with neural networks, when neural networks became all the rage, and then they died away in part because of the hype. And everyone saw it and they said, you know what? Everyone's been telling me how great neural networks are, but it's not working. And I fear that many people will conclude that data science and machine learning doesn't work because it's being applied in a way that's not really addressing the core questions of the organization.
Really, really good insight there. Dean, thank you so much for being generous with your time. This has been awesome. Is there anything that you would leave our listeners with? Are there any opportunities out there? Is there a perspective on data you think is just critical for more people to hear at this moment in time?
The one quick thing I'll add is don't give data preparation short shrift. I mean, I've talked about the importance of clear objectives with the stakeholders, but from an analyst perspective, being very curious about your data and ask the question, why is the data looking like this? Noticing those outliers, the unusual values, anything that is not easily explainable in the data, it's important for us to chase it down and to fix it, or at least turn it into a version of the data that the algorithms can use better. So data preparation really does take 3/4, 80% of your time before you build your first model. Don't give that short shrift.
Wise words. Dean, thanks for joining us. And to everyone listening, we'll see you next time.
I'm Sophia Bush, and you've been listening to Hidden in Plain Sight from Mission.org. This podcast is sponsored by our friends at Splunk, the Data to Everything platform. In today's data-driven world, every company, big or small, new or old, is sitting on terabytes of unused, untapped, and unknown data. Splunk helps turn all that data into action. Using cutting-edge AI and machine learning, Splunk delivers real-time predictive insights that will help you on your mission to change the world. With solutions for IT, security, Internet of Things, and business operations, Splunk empowers people to make faster, better decisions and take action to get things done. It's time for our data to be more than a record of what happened. It's time to make things happen.